Let's keep with our review in the prerequisite chapter. This time we're going to look at section 2 of the prerequisite chapter on linear models and rates of change. Well, it's not that dramatic. Anyway, when we're graphing lines and linear equations in two variables, we did a little bit of that in section 1, but we go all the way back to middle school, most likely, that we first started graphing lines. And one of the main concepts of graphing lines, of course, is how the line is slanted, or the idea of slope. And I have a definition here that the slope of a non-vertical line excuse me, is the measure of the number of units that the line rises or falls vertically for each unit of horizontal change from left to right. And you probably remember it as rise over run. So if I'm given 2 points, x1, y1, x2, y2, where x1 is not equal to x2, then the slope of the line that passes through those 2 points is m delta y over delta x, which is y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Now, first off, delta typically means change mathematically. So when you see delta y, you're talking about the change in the y's over delta x, the change in the x's. And that gives us our ratio here, which we call slope. Now, they use the letter m for slope because it comes from the French word monter, which is like to climb the slope of a mountain. Now, remember that the two subtracted coordinates, the x sub 1 and the y sub 1, come from the same point. You could have it the other way around. You could have y sub 1 minus y sub 2 over x sub 1 minus x sub 2, as long as you have the same point where we're getting our subtracted coordinates. Now, this is also saying a non-vertical line, because when we talk about the slope of a vertical line, we say that there is no slope, or that the slope is undefined. And later on, we'll think of this almost in terms of the idea that the line is infinite. It has slope that is infinite. Now, there is positive slope, and of course, positive slope means the line goes up and to the right. Negative slope, it goes up and to the left. Zero slope, which is a horizontal line going straight across, and then undefined slope, which is that of a vertical line. Now, what I'm going to do is I'm going to plot the points in these next examples here. I'm going to plot the points, and I'm going to find the slope of the line that passes through them. Now, the first time I do this with part A here, I'm actually going to graph the points first. I'm going to graph 3, 1, 2, 3, and then negative 4 is down 1, down 2, down 3, down 4. I'm going to try to make this close. Hopefully that looks like about, yeah, it doesn't look too bad, maybe a little too high up. And then the point 5, 2, 1, 2, 3, 4, 5, then up 2, about here. And so if I wanted to look at the change in the y's or the change in the x's, I could actually count how many spaces up till I'm even with it. So that would be 4, 5, 6 spaces up. And then I could count how many spaces over, in this case, to the right, which would be my horizontal change, or the change in the x values, and that's 2 to the right, 2 units. So I can figure out the slope just by looking at rise 6 over run 2. Now, when the second sneeze of my videos, when I'm looking at the slope of a line, looking at the points themselves, I look at typically the one that's lower, so that I'm always going up first, and then I'm either going to go right or I'm going to go left. So if you go up and then right, that's a positive concept over a positive concept. If I go up and then left, it's a positive concept over a negative concept. And my slope is going to be 6 over 2, which is 3. Now, we normally write our slope as a ratio, like a fraction. However, if it turns out to be an integer, we'll just go ahead and leave it as an integer, like that. Now, the actual graph of the line, I gotta grab a ruler here somewhere. What I do with my ruler, oh, there it is, way over here. And then I can draw my line that goes through those 2 points. And there's the first part. That's for part A. Now, if I choose to do this using the slope formula that's given above here, then my slope is going to be the y value subtracted, the y value from the second ordered pair minus the y value from the first ordered pair, x value from the second ordered pair minus the x value from the first ordered pair, and 2 minus a negative 4 is 6, all over 5 minus 3 is 2. Look at that, I get slope 3 as well. I don't like doing it this way unless that my graph is given and I don't have much else. Now in this case, I'm going to find the slope of this line, but first I'm going to graph the points and I'm going to draw the line in. So I have 2, 1, and I have 2, 5. 1, 2, 3, 4, 5. Do you notice what I have here? I have what appears to be a vertical line. Now, the problem is my straight edge won't line up with it until I scoot it all the way over here because of the arm of the camera. And hopefully I've got this halfway lined up. And there's my line. And it is a vertical line. Now, I said just a second ago that a vertical line, we say that it has undefined slope. So if you're to use the slope formula, you're going to notice here that your slope is 5 minus 1 all over 2 minus 2, which is 4 over 0. And of course you cannot divide by 0. This is undefined. Okay, nothing snazzy there. Let's go over here. Page 2. Now, if I am given information about the line, maybe I'm given a couple of the points, or I'm given a point in the slope. Let's see if I can get this evened up here a little bit. Still adjusting here to this camera. The point slope form of the equation of a line is probably the best route to go, and it is something I'm sure you remember from your algebra days: y minus y sub 1 equals m times the quantity x minus x sub 1. Now, I like to use this when I'm writing the equation of a line, although I like to use slope-intercept form when I'm graphing. We'll mention that in a minute. An equation of a line with slope m passing through the point x sub 1, y sub 1 is given by this form. Now, I've got a couple of examples here. It says find the equation of a line with the given information. M, the slope, is -2, and it passes through the point -2, 1. Well, this is going to go into here for the m, and this are going to go in for the x sub 1 and the y sub 1, respectively. So let me write out the point slope form, and then I'm going to plug this in for m. This goes right in there, and I'm going to plug this in for x sub 1 and this in for y sub 1. So I have y minus 1 equals, oops, almost wrote a +2. It's a -2 in for m times the quantity x minus x sub 1, which is a -2. So minus a -2 is +2. And that is the equation. You could stop right there based on the instructions given for this problem. That would be good enough. Now, if you want to go ahead and distribute and isolate the y, that's fine as well. Now we're going to do one where it's just giving 2 points that the line passes through. Of course, that'll make it a unique line, but we need the slope. We have a point. In fact, we have 2 of them, but we have to have the slope. And that's where the slope formula from before comes into play. Now, I know that's tough to tell, but that's a 9 right there. Okay, so the first thing I'm going to do is find the slope. 9 minus 3, y sub 2 minus y sub 1, over 1 minus a -2, x sub 2 minus x sub 1. If it helps you, you can think of this as x sub 1, y sub 1, x sub 2, y sub 2. I just think of it because this is the first one and that's the second one listed. So I have 6 on top, and 1 minus a -2 is a +3, so my slope is 2. Now, it does not matter which point I take. I'm actually going to take 1, 9 because I try to avoid negatives when I can. Go back to y minus y sub 1 is equal to m times the quantity x minus x sub 1. I'm going to plug the 2 right in here, and I'm going to plug the 1 and the 9 in for the x sub 1 and the y sub 1 respectively. I know it says x sub 2, y sub 2. You should follow that. Y minus 9 is equal to 2 times the quantity x minus 1, and I'm going to leave my answer in this form. All right. Now, slope of a line can be thought of in one of 2 ways. It can be thought of as a ratio, which is the way that I typically think of it, or it can also be thought of as a rate, and the rate typically comes into some of the application problems. So we'll do an example here in just a second. Now, how can you tell if it's a ratio or if you can tell if it's a rate? Well, first, if the x and the y axes have the same units of measure, slope is a ratio. It does not have any units. However, if the x and the y axis have different units of measure, maybe one is distance, one is time, then the slope is a rate or a rate of change. And you will see rate of change, oh yes, on the AP test. So this is something you're going to want to remember. All right, a small business purchases a piece of equipment for $875. After 5 years, the equipment's going to be outdated and it's not going to have any value. So in the first part here, we're to write a linear equation giving the value y of the equipment in terms of the time x And notice here, oh, you can't see that, can you? Here we go. After 5 years, the equipment will be outdated, having no value, and we're going to write a linear equation given the value y of the equipment in terms of the time x, x being in terms of years and y being in terms of money, and x is between 0 and 5 because it has no value after 5 years. It's not going to have negative value. To solve this problem, and I'm going to see if I can do this carefully. I didn't have much space there, so I'll see if I can just combine a couple sheets of paper here. All right, so for part A, to find the linear equation, I need a couple of points. And the points are as follows. When the time is 0, when x is 0, the value is $875. Can you see that okay? You should be able to see that just fine. And then 5 years later, when x is 5, y is 0 because the value is, well, it has no value. So that's good enough to get me started to write this equation that part A is asking for. So first I find the slope. Now my slope here is not going to be a ratio, it is going to be a rate, and it's going to be dollars per year. This is dollars and this is years, so I end up with negative 875 all over a positive 5, which is negative 175. So in terms of the idea of money, this would be this piece of equipment that the business purchased is losing on average here $175 each year. This would be in dollars per year. But I'm not writing it that way. I want the equation first. So I'm going to go back to my favorite guy, point slope form. And I'm going to substitute in. This goes in for the slope here. And I'll keep life easy here. It doesn't really matter which one. I'm just going to go ahead and use this one, and you'll see why in a second, because that's going to go there, and I'm going to get a nice 0 right there, which is always convenient. I have y minus 875 is equal to negative 175 times x minus 0. Of course, x minus 0 is x. So I have y minus 875 is equal to negative 175x. And because it asks for the equation giving the value y, I'm going to isolate the y. I'm going to add 875 to both sides. And this is the answer to part A. This is the equation that they're asking. Y is the value of the piece of equipment, and x again is the amount of time that the business has owned it. Now we're going to find the value of the equipment when x is 2. So this is pretty straightforward. So after 2 years, how much is this thing worth? Well, I need this equation. That's why I did that step first. And I'm going to substitute a 2 in for the x. And I get y equals negative 175 times 2 plus 875. Y equals negative 350 plus 875, which adds up to what? 525. So what does this mean? Find the value of the equipment. The equipment is worth $525 after 2 years. With story problems, we want to write our answer out with a short sentence whenever possible. All right, then part C says estimate to the nearest hundredth the time when the value of the equipment is worth exactly $200. Well, in this case, the value is 200, and we're looking for x, so I'm going to go back to this guy, but now I'm going to plug 200 in for the y. Didn't give myself a lot of space here, did I? That wasn't such a smart move here. So I'm going to subtract 875 from both sides, and I get negative 675 equals negative 175x. I'm going to divide both sides by negative 175, and I don't think that's going to go into it evenly. And that's going to give me x is equal to, now it's set to round to the nearest hundredth, so I get Mr. Calculator out here. Normally I like to leave my answer as exact as possible, but in this case it's an application. It has to do with the value given in it's $200, and you're trying to find the time, and it tells you exactly what to round to the hundredth. Now if you're to round and it doesn't tell you what to round to, in calculus you might as well get used to rounding to 3 decimal places, because that's what they want to see on the AP test. So let me clear this out. This is from the last video, I think. So I'm going to take 875 and I'm going to divide it by negative 175. Oh, actually, it's a negative divided by a negative. Let's try that all over again. I'm going to take negative 675 and divide it by a negative 175. Of course, I already knew it was positive. And does that look right? That looks right. And I'm going to get 3, approximately, with the little dot above the equal sign, 3.857 or 86. So, after 3.86 years, the value of the equipment is $200. Nice little short sentence there. All right, now it says here, when you're doing these types of problems, the slope is going to be the average rate of change, and the average rate of change is typically over a time interval. All right, now that's an example where the slope was a rate of change, but in this next example, you're going to see that the slope is actually going to turn out to be a ratio because the units are the same. It says that a ramp rises to a height of 9 feet on a loading dock, so I'll try to draw this in and make it look official. Here's my level ground. Here's my loading dock. Let's see if I can draw this worth a darn. And let's see, let's make it look as decent as possible here. So let's say that's our loading dock here, and that this is 9 feet tall. Remember, the single tick mark means feet. And our ramp is going to go up like this. Now, we don't have to determine the angle, but we definitely have a right triangle here. And this, the ramp that, let's see, on the loading dock, that is 33 feet long. The loading dock is 33 feet long, so that's down here. Guess I got to read the problem, and you're to find the slope of this ramp right here. Well, the way I've drawn it, it's going up and to the right, so it would be positive. It is vertical change over horizontal change, so the slope would be 9 feet over 33 feet. The feet cancel. I can divide top and bottom by 3. I get 3/11. So it's just a constant. It's just a number. So find the slope of the ramp. The slope of the ramp is 3/11. And there's my answer there to that one. Again, it's a story problem. Write it out nice and neat. All right, now, when you're graphing a linear model, and we haven't done one of those yet, we just worked with a couple of examples, the preferred method to write the equation is slope-intercept. As I mentioned before, slope-intercept is really nice to have when you're graphing because it gives you all the information that you need to find 2 points on the line. And of course, 2 points are all you need to determine a line. It gives you the y-intercept, and it also gives you the slopes where you can find a second point. And this is what we call a slope-intercept form. You guys, I'm sure, are familiar with y equals mx plus b. There's your slope, and there's your y value of your y-intercept. So in problem, in the examples here for parts A, B, and C, I'm going to graph, and I'm just going to go ahead and put it on the same set of axes here. I'm going to graph these equations here, and they turn out to be linear equations, all 3 lines. I just got to kind of scoot this over here. And hopefully you can see that okay. There's the equations. I went ahead and wrote them down again here. We'll start with part A. My slope is 3. My y-intercept is 0, -2. Graph the y-intercept, which of course is on the y-axis. Notice again, my axes are drawn out. I have arrows on the ends of my axes. I have a scale set for both the x-axis and the y-axis. So I graph the point that I'm given, that I have here, the y-intercept. And then I use the slope, which is rise over run. I'm thinking 3 is 3 over 1. So I go up 1, 2, 3 units from the point that I started with, and then to the right 1 unit. My line goes up and to the right. That would definitely represent positive slope. And then I'll try to draw this halfway decent. Now, you know, if you're drawing this out, draw it big enough so that I can see it. Don't put a little bitty line like this or something where I have to try to interpret that you have it right. Draw your nice and big there so it goes through the points, and put arrows on the ends because it is a line and it represents it goes on forever. Now the next guy here is not really in slope-intercept form, but yes it is, because y equals mx plus b, There's no x term, so that means my slope is 0. So this is the same as y equals 0x minus 3. The constant term, the b. So my slope is 0, which means that it's horizontal, and that my y-intercept is going to be 0, negative 3. So let's see, let's go over here, try to keep it level. 0, negative 3, 1, 2, 3, there it is. It goes through that point, and it has slope 0. So that would mean it would go 0 up or down and then right or left. So I'm just going to draw a horizontal. As soon as I see that the slope is 0, I don't even plot another point. I know what a horizontal line looks like, and I graph it. So here, this was part A. This is part B here. Now on this third part here, it is not in slope-intercept form. So I'm going to just bring it up here. 4y plus x minus 8 equals 0. To put it in slope-intercept form, I need the y by itself. So I'm going to subtract x and add 8 to both sides. All right, and then I'm going to divide through by 4. Now this is like a negative 1, so if I divide it by 4, I have negative 1/4 x, and then of course 8 divided by 4 is 2. I can see my slope is negative 1/4, and that my y-intercept is 0, positive 2. So back to the graph here. 0, 2, start with the y-intercept, and my slope is negative 1/4, so that's rise over run. Now if you want to, you can think of this as negative 1 over positive 4 or positive 1 over negative 4. I always think of my negatives up in the numerator, so from here I'm going to go down 1, and then I'm going to go right 1, 2, 3, 4 units. And I get my second point. Remember, you don't start at the origin, you start at the y-intercept, unless of course the origin is the y-intercept. Now I've got my 2 points, get my straight edge, graph a line. Now again, if you're doing graphs and they're on a test or they're on a quiz or they're on some assignment that I'm going to grade, I would like for you to use a straight edge and be neat. I don't want you just to freehand it and get it over with. You'd be surprised some of the silliness that I sometimes get turned in when students are trying to get it over with quickly and not really take any pride into what they're working on here. So now I go to this page right here. It says, because a vertical line cannot be written in slope-intercept form with undefined, we use the general form. Now, point-slope form and slope-intercept form are great. Point-slope is great for writing the equation line. Slope-intercept is great for graphing. But if it is a vertical line, the slope is undefined, and you can't write in the word undefined into the m in the equation. So there is another form. Actually, there's a couple of different forms. This form here, the book entitles as the general form. Some books call this the standard form, where they put the constant on the other side. All right, but A, B, and C are traditionally written as integers, and we like to keep A as a positive number wherever possible. But remember, if it's in this form, both A and B cannot be 0, because then you don't have a line anymore. Now, I'm going to use that form, but first I'm going to talk a little bit quick about slopes and parallel and perpendicular lines. Now, parallel lines are lines that do not intersect, coplanar lines that do not intersect. I'm going to try to do that with 2 pencils here. Best I can. That's not too bad. And notice that these lines don't intersect, at least they don't look like they're going to, and that they also are slanted the same way. So what we determine from this is that parallel lines must have the same slope. So 2 distinct non-vertical lines are parallel if and only if, IFF by the way, is shortcut notation for if and only if, their slopes are equal. Now, vertical lines are parallel to other vertical lines, but when we're talking about slopes, we can't talk about vertical lines, so we say 2 non-vertical lines are parallel if and only if their slopes are negative. Now, perpendicular lines, you may remember, are lines that form right angles. So I'm going to try to put that there in such a way that they look like it forms right angles. Well, you can see even with this terrible looking example of pencils that one of my lines has got positive slope and one of my lines has negative slope. So the slopes will be different. There will be opposites of one another, but it's even better than that. 2 non-vertical lines are perpendicular if and only if their slopes are negative or opposite reciprocals. So that means if this is the slope of line, the one line, and this is the slope of the other line, that m sub 2 has got to equal -1 over m sub 1, the opposite reciprocal, or the negative reciprocal. And that's really useful, that parallel lines have the same slope and perpendicular lines have slopes that are opposite reciprocals. Now let's use that and the idea of general form here to answer this example. Find the general form of the equation of a line that passes through the point 3, 2, and is parallel to this line, 3x minus 2y equals 6. So I'm going to take 3x minus 2y equals 6. I'm going to solve for y and put it into slope-intercept form, because I need to know the slope of this line if the line I'm trying to find is parallel and have the same slope. So I'm going to subtract 3x from both sides. I like to put that first. Then I'm going to divide through by -2, and I get a positive 3/2 x minus 3. I'm not really worried about this part. This is what I need. I need to know that the slope is 3/2. So let me write that down. The slope of the line is 3/2. Not only is the slope of this line 3/2, but the one that we're trying to find. I have a point, I have the slope, I go right back to this guy. If you write it down every time that you go to use it, after a while you have it memorized. And so I'm going to plug this 3/2 in for m, and I'm going to plug this in for x sub 1 and y sub 1, and I get y minus 2 equals 3/2 times x minus 3. Now, as I mentioned, I don't want any fractions, so I'm going to multiply both sides by 2. 2 times this side, and 2 times this side, and I get 2y minus 4 equals 3 times the quantity x minus 3. I have 2y minus 4 equals 3x minus 9. Now I have the x's and the y's on different sides. I need everything on the same side. Let's go back to here. Everything on the same side. And I want the coefficient of the x to be positive, which it is right now. So that tells me I'm going to subtract 2y from both sides, and I'm going to add 4 to both sides. And if I do that and bring it over here, I'm going to have 3x minus 2y minus 5 is equal to 0, and there is general form right there. Again, I subtracted 2y, that's the minus 2y, and I added 4, a -9 and a positive 4 is a -5. Now I'm going to do the same thing, but this time perpendicular to this line. Now I already have the slope of this line. So the slope that I want to use is going to be the opposite reciprocal. The opposite reciprocal of 3/2 is -2/3. So now I have the point, I have the slope right back to this guy. So I have, let's bring it up just a little bit here. Is that level? That looks level. I get y minus, where's my point, 3, 2, y minus 2 equals -2/3 times x minus 3. I'm going to distribute here, and you say, well, you didn't distribute last time, you just multiplied by the denominator. Well, I'm going to distribute this time because I can see the 3 is going to cancel with this 3, and that maybe saves me one step, maybe not. -2/3 x, negative times negative, plus 2. The 3's would cancel. Now I don't want that fraction there. I am going to multiply through by 3. 3 times the left side, 3 times the right side. I get 3y minus 6 is equal to -2x plus 6. Well, this time the coefficient of the x is negative. I don't want that, so I'm going to add 2x and bring it over to this side, essentially. I'm going to add 2x and subtract 6. And I'm going to get a positive 2x plus 3y minus 12 is equal to 0. And there's my answer to this guy. Now, I think you will find that with a little practice, because you've done this before, but with a little practice, you'll be right back to the skill level that you had before, back in your Algebra 2 days and your pre-calculus days. And again, I thought the lesson went nice and smooth, so maybe just a little bit more applause. All right.